used in our area. We need just to design our building to earthquakes. So we will see also a demonstration how in Japan the effect of this base isolation, how it will reduce the effect of the buildings. So we see this building, this one with base isolation. Okay, this is the base isolation. Okay. So when we have shaking of the grounds, okay, the buildings, it will remain stable. Okay, we have the tube mass dampers. They are a large mass on the top or maybe on the upper floors of the buildings. Let's say if you are in the train, okay, and the train launch starts moving, you will go to the other part. يعني انت هترجع لورا. إذا الترين بلش انت هترجع لورا. The opposites. Okay. So if you are fixed in that train, okay, you will work against the movements. Like this, the tube mass dampers. When the building goes to the side, to the right, the tube mass will go to the left. لما هيكون a very huge weight هيرجعه لمحله. So it will turn back. This is the Taipei Tower, one of the highest buildings over the world, that used the strategy of this tube mass damper, okay, to also reduce the effect of earthquakes or wind pressure, any lateral pressure that may cause. Also, we need to take care about the pounding effect. What do we mean by pounding effect? Pounding effect, when the buildings are close to each other, they may hit each other. So we need to leave a space between buildings for not having the pounding effect. So finally, let's finalize. Sure, one of the major points to study building the architectural features, because we have irregular structures, irregular dimension, it will also may cause us to have an exhaustive design, so this buildings will have a good performance to the earthquakes. The building should be light. For that, we look forward to lightweight materials and lightweight concrete. Okay, we need to be more simple and symmetric and regular. We need to take care for the pounding effect by the agency of the buildings. Okay, flow of inertia forces to foundation. We need multiple defense lines by lateral force resisting system, by frames, shear hooks, bracing elements, and so on. Okay, we need to improve the stress and activity of the buildings, and the distribution of mass is very important, because what causes the building to move the mass. So the force is related to the mass. When we have a regular distribution of the mass, it will cause a better performance of the buildings. Maybe I will go a little fast, but for the time, the last to allow times for questions. So thank you for your attendance. And okay, do you have any questions? هل في عندك سؤال؟ تفضل.
When you're in a tall building and an earthquake happens, and you're on the top floor, do we go on the roof or we go down?
Maybe I intended to mention